met up properly. So to meet the demand of electrical supply as well as the demand as well as supply, so integration with smart metering is another issue.
Maybe smart metering may be the primary factor now because this due to EV maybe.
This is how this is
If
smart.
EV may not come in effect, then might be possible that smart metering may not be there.
No. Smart metering concept is most important because we are not able to identify how much is the transformer losses are there, how much is the exact ATC losses are there. So to bridge this gap, to fulfill this gap, this smart metering concept is generally we use because like suppose in general terms we are
But
using
both the proposals is coming on the same time.
on the same platform like the electric
2026 all meter will be smart. Again EV has come on the same time.
Exactly.
So maybe this may be one of the issues.
This is one of the issues. This is one of the issues. So we have seen that ultra fast growth is there, like from the last scenario, like from the back to the slides, this charging stations has been increased. So we have seen a major turns, major manifold in the years that charging station has been increased. Still, we have EV to charger ratio is quite lag behind as compared to global benchmarks like China, as compared to Europe as well as from the US. So in India, we have state leaders like Karnataka, Maharashtra, and Uttar Pradesh is the most leading in infrastructure. Most leading states are there which are using the infrastructure of the electric vehicles. Functional gaps. British Bharat Petroleum Corporation charges, Corporation Limited charges are there, Tata Powers are there, which are helping us to make the chargers, helping us to make different chargers, slow charger, fast charger, and they are also maintaining 84% uptime. Uptime basically means their efficiency is nearly about 84%. So still we are in a situation that we are bearing a 16% losses here also. So this is another research area which is opening the eye of the researcher that we are dealing with 16% losses, how to minimize that losses. So these are the general power flow in electric vehicles as you have observed in various presentations also. Different modes are there, like first is this part is the hybrid electric vehicle in which you have the facility that you can use the electric vehicle as well as the fuel tank of petrol or diesel, something like that. But diesel is normally not connected, it is connected with petrol tanks. Whereas the second model is the only for the purely electric vehicle. So in this we have to hybrid, we have to phenomena, motor generators are there, power converters, batteries and chargers are there. Whereas alternatively we have internal combustion engine as well as a fuel tank. So in case of additional supply, in case of alternate supply, you can use this system. Whereas in the complete electric vehicle system, like we have Tata Nexon right now. So in this we have completely electric vehicles. So only battery system is there, which is connected with the motor generator and controlling unit is there.
Sir, out of hybrid and simple electrical, which is more costly basically?
Which is more costly?
Yes.
You can tell me.
No, I want to ask this.
According to the circuit diagram, which is more complex?
No, actually, it should be like
Which is
hybrid. It should be hybrid.
It should be
but
hybrid.
EV is why EV is so costly? My question is
why EV is so costly?
Yeah, it should be
the cost.
Hybrid should be costly.
I agree. I just come to your point. The cost of electric vehicle is majorly dependent upon the battery system.
Battery is also there in hybrid.
Battery is also there, but the capacity of the battery is quite low as compared to pure electric vehicle. In this hybrid mode of electric vehicle, the sizing of the battery is somehow optimized, that we have the provision to adjust the petrol fuel tank. If the sizing of the battery is increased, the specification of the battery is ampere hour, AH. If we have an inverter battery, we have 150 AH. Like suppose same in the phenomena, same as the specification for the batteries for the electric vehicle. They have the capacity in ampere hour. So ampere hour basically means how much current it can take it in an hour. So if the current is increasing, if the sizing of the battery is increased, so it means that the current capacity is also increased. Since we know that the current is generating square is proportional to square, heat losses is I square R. If we increase the current, the heat losses will increase square times. So if square times increase, if then we increase the size of the battery, the current is increased, and if the current is increased, this whole assembly is associated with fuel tank.
सर मेरा क्वेश्चन है, मान लो इक्वल बैटरी है, उस केस में भी ईवी महंगी है सर, ऐसा क्यों?
I come to that point. I'm coming to that point. So in that scenario, the cost of insulation is very high. So that is why we reduce the cost, we reduce the sizing of the battery. Now your question is, if we place same amount of battery specifications with this, the cost of electric vehicles are high. Why? Because according to the taxes. There is taxes on, the major tax concern is the battery, this control unit. We are not supposed to manufacture that control unit. These control units are imported. Where these are imported? They are imported from South Korea. They are imported from Europe. They are imported
यानी कि
from.
सरकार चाहती है इस ईवी को, लेकिन खुले मन से, खुले दिल से।
Sir, खुले in the sense that we are not able to manufacture those components. We are taking the components in the importing. We are importing the components. If we are importing the components, we have to pay the duties. However, the government has given the subsidies on the electric vehicles. Nearly about 1.5 lakhs subsidies are there. So the government is promoting. The government is saying that we want to reduce the burden on the electricity grid. The grid is running in a very tough situation. So to minimize that issues, the government is promoting subsidies on electric vehicles. However, there are certain issues are there. The range is very limited. The charging time is very high. So these are the major issues that normal human beings are quite thinking to purchase, to buy the electric vehicles. So if we're talking about the electric vehicle charger, there are certain types of charger depending on the level of charging, level 1, level 2 or fast charging. If we are talking about the types of charger, we have conductive charging or we have the wireless charging. However, in India, we are not supposed to implement the wireless charging, whereas in France, whereas in Europe, in China, the wireless charging techniques are there. If you are standing in a red light traffic lights, the special zone is there for the electric vehicles. You have to just put your vehicles on that near to zebra point, and automatically your vehicle will start charging. Current will take the charge from the ground. Certain connections are there, and it will charge a battery. But this phenomena is not implemented, will not be implemented in India because according to various situations, like we have different potholes in Indian roads, we have different issues in Indian roads. So this is another concept that it is not.
Electromagnetic radiation may also affect the health of the person also.
Sorry, I didn't understand.
Radiation, electromagnetic radiation from the wireless charging,
Definitely.
it may affect the person standing
Definitely.
side by the
they have the provisions to mitigate the radiation. That
Insulation.
that wing is but entirely different. Traffic lights are there, but that wing is entirely different, which will the range.
But then person is also sitting in the car.
So these are the different type of chargings. If we are talking about the schematic diagram of electric vehicle charging infrastructure, as we know that the power is generated from these different sources like coal, gas, oil, nuclear. These are different sources, as you all know, general source of generation, traditional source of generation. The power is transferred. The power is transferred to the transformers and from the higher antennas or higher transmission towers, and from that transmission tower to the transmission station. If you are able to see these different lines like dark lines, black dark lines, and these red lines, we have a different framework. Framework basically means we don't only generate the power, we don't only distribute the power, we don't only utilize the power. This is the simple aspect. So it's generation of supply, transmission and distribution. This is a simple supply. But what will happen in case of cyber attacks? What will happen if somebody stole the data of these coal mine, the coal station or nuclear station? If any country or any hacker will change the data of nuclear plant or coal plant, it will adversely affect the generation. So these the second line is if you are able to see these red lines, these are the wired communication lines which is running starting from the generation point. Every generating station, I am not talking about only for the coal station, any generation station, anything, that wireless communication or wired communication line will run and it will go everywhere till your either your industry or your commercial building or your college, anything, anywhere you go, that communication line will travel along with you. What will happen to that? It is a mandatory guidelines that when you open any building, when you open any mall, the government guidelines is that if you want to take a connection, your communication line is to be installed in that. What is the impact of that? In case of any data breach, in case of any major failure, in case of any major attack, the government has the data that at which instant of time or at which place the data breach in case of electricity is there. So to mitigate that gap, to mitigate that fault, that communication line is there. In case of any failure is there, any transformer failure or any transmission tower failure are there, hardly matters. It will these dotted lines or these red lines will directly let us know the nearest utility control center or any substation that your area is under effect. So you are under cyber attack or data breach is there. So kindly change the system or switch off the system in case of any data breaching to avoid the mishap. So for the EV charging in industries, same power is generated, the transformer, transmission lines are there, distribution stations are there, and it will go to the residential building, commercial building. For electric vehicle, we have public or private charging options are there. For like suppose we have in the near about highways, we have charging stations are there, and it will have the continuous monitoring that today we will charge nearly about 5 to 6 vehicles depending upon the location, and for that we need different amount of current are there. So they have to give the demand to that particular utility, particular grid substation. That grid substation will give to the demand for that particular utility control area. That utility control will send the demand key. Sir, today we are generating, the weather is in the summer session or the transportation of vehicles are very high. Vehicles are transporting very high. So we need additional amount of supply. So kindly increase the generation. So this scenario will work in this manner.
I have a solution for the same, maybe to 25%. Like we can install solar charging stations.
Agree. You can the solar
Up to
charging.
25%.
Okay. So can you tell me the directional flow? Because
No,
this-
not connected with this grid.
just one minute. Whatever I am saying that you are generating the electrical supply from these poles.
Standalone.
Standalone single model
Solar.
supply. Single model supply. The supply is coming from this, and it will
Standalone solar EV charging stations.
standalone solar EV charging station. Okay, no issues. So for that electric vehicle standalone,
Again, we require that.
you require battery. ठीक है, the cost will increase. You require solar panel, the cost will increase. Not even the approximately 10 kilowatt solar panel is required to charge single battery. The cost of 1 kilowatt solar panel is 50,000. So you can imagine if you have 50,000 for 1 kilowatt.
Again, as 25% I have said.
So in case if you are taking that large amount of money, so why are you investing that large amount of money in a single frame for to charge one electric vehicle? If you are in that amount of money, the simple IEC battery, IEC engine is there for
Pollution.
a single Audi is there. You can purchase that Audi. You are investing the amount near about Audi, and you are charging only one or two vehicle. So that is not optimizing. That is not the optimization factor. How you can optimize from the given resources, that is the main point of concern. We are adding system, hardly matters. We are increasing the cost, hardly matters. But what about the payback period? In how much amount of time we will pay back from that system? That is the most important issue. What are the sources we have available? From that sources, can we deploy these sources to take the maximum advantage to the society? This is the major concern. So for power infrastructure in electric vehicle charging, we have AC grids, we have onboard charging, we have offboard charging. Onboard or offboard basically means level 1 or level 2, level 3 charging. Onboard charging means it will take large amount of time to charge your vehicle. 7 to 8 hours is generally required to charge the vehicle. Whereas for the offboard charging, level 2 or level 3 chargers are there, which will charge your electric vehicle in a very fast manner. 15-20 minutes are there to charge the electric vehicle, but it will take large amount of current. How to handle that large amount of current from level 3 charging? It will directly affect the grid. So this is the major concern, because if we are using only 2% electric vehicles are there, and all the 2%, let us suppose all the 2% are using the fast charger. So that 2% will affect the present grid scenario. And if all the 2% are using the fast charging scenario, the situation is that you have to change the electrical network. The present system that we are using, the 50 Hz electrical supply we are using, we have to change the entire system. So we are in a position to change the system? No. We are not in a situation to change the 50 Hz system, because it is a very traditional system and it is highly implemented in all the parts of India. So it is quite to next to impossible to change the scenario. So how we can deal with it, how we can have the alternate solution, like in the onboard charging and offboard charging, we are using the tariff system. For what is the cost of electrical supply to charge the electric vehicle per unit is nearly about 10 rupees. Per unit is 10 rupees charging unit. So for if any person want to charge their electric vehicle in a very fast manner, he has to pay 20 to 25 rupees per unit. If somebody is in a very needy situation, he will come and pay that major amount and charge their vehicle. But if somebody is going on a tour or simple transportation is there, he can say, okay, 30 minutes, I will go from point A to point B. From that point B, I will charge my vehicle. I have 7 to 8 hours working hours or something like that. So I will go there, I will charge there 30 minutes. why I have to pay 20 to 25 rupees, 20 to 25 rupees per unit. I will adjust with 8 or 9 rupees per unit. So for EV charging infrastructure system, we have different type of chargers, AC as well as DC. For DC chargers, it is converting from AC to DC the charging which is available at the standing point